person next to you. Just introduce yourself, know each other. Just 2 more minutes. Um, I'm going to try hard and remember all of your names, but it might take a week for me. Um, Tomorrow when you come, would you please bring a piece of paper, write your name, fold it like this, okay, and put it in front of you so I can know your names. I'll start practicing, okay, as I'm speaking. I'll practice your names, but I'll do that in 1 week. I need some time for that, okay? We'll do that. The second thing I want to say is academic integrity, okay? We want to be sincere. We want to respect each other, okay? Nobody's superior, nobody's inferior. We're all the same, all right? We're here for learning, that's it. Only one reason, nothing else. We're here for learning, okay? Nothing more than that. If there is anything else, it has to be outside of the room, okay? In this room, learning. That's all we'll do, right? But put your 150% effort on it. Not even 100, 150% effort on it in terms of learning. Because I don't know, you paid for this program, right? So be honest to yourself and learn as much as you can. Ask me, stop me. There's nothing wrong. A scientist is a person who knows the mistakes in their research. I didn't say this, Albert Einstein said this, okay? First of all, you need to know the problems you have, then you will actually learn. Unless you come out and say something, you will not know it is correct or wrong. It is totally okay to ask a wrong question. We're all students, all of us. We're all on what we call a learning curve, okay? Some of us may be at there, some of you are here, doesn't matter, we're all on the curve. We're all learning, including myself. I'll be learning from you, okay? I will try to do my best. I'm not going to tell you that I know everything. No, I don't know everything. But I will do my best. If I don't know, I'll find the answer for that, okay? But I'll try to do my best. Likewise, you want to be sincere. Ask me, don't feel shy at any time. No need. We're all one unit, one group, including myself. Okay? All good? All with me? All right? Louder. All with me?
Yes, sir.
Yeah, that's what I want. That energy is what I want. Okay? So today we'll start with this introductory class. This is like I don't want to really bother too much about this particular lecture. This is kind of giving you a snapshot about all the different things you will learn in the next 10 days. I'm going to talk about greenhouse designs, I'm going to talk a little bit about hydroponics, I'm going to talk a little bit about environmental control, just as an introduction, first class. But then we dive into light, temperature, water, nutrients, things like that, all the factors that plants require for their growth, okay? So just enjoy today's first lecture. It's a very general content, very easy content. That's the reason why I've actually typed everything for you, right? You can just read and go through, but this is the only lecture where you find that type of typing. From lecture 2 onwards, some bullet points, you got some space, okay? If you want to write it down, I'm hoping that you didn't receive these PDFs, you did you? Yeah, if you have a laptop, you can type onto it, that's great. If you want to write down extra material, feel free. But write down that some content. I have most of the content on the slides, but I may speak a little bit more than on the slide, so you may want to write it down. All right? They are trying to make this a PowerPoint presentation so we can see the entire slide. So what I want to do is let them do it, but I wanted to start by saying that, a greenhouse is simple structure, right? It is a structure. It's got a metal frame or a wooden frame, whatever it is. You cover it, right? When you cover it, you're confining whatever you go inside from external environment. So the external environment has a little impact, but truly speaking, even you cover it, there is an indirect impact of the external environment. You learn about it. If you put a cover on anything, it's going to get hotter inside, right? Why is it happening? Why does it get hot? Anybody? I'm going to ask a lot of questions, okay? This is how I teach, all right? So feel free to answer. When you put a cover on something, why would it be hotter inside? What's happening? Flow of air. But what is the source of that? What is the source of that heat inside? Somebody said sunlight. The sunlight is still coming in, right?
but it's not going out. He said there's no airflow. So the heat builds up. That's called greenhouse effect, by the way. That is what they use for global warming, greenhouse effect. Carbon dioxide up there in the atmosphere is like a cover and it's holding the heat inside. The heat is not escaping. That's why the global temperatures are going up. The same thing with the greenhouse too. You have a structure, you put a polyethylene, a glass, or a polycarbonate, it heats it inside. But then if you manage that environment inside, what you're doing is you are creating an optimum environment inside. You're protecting the plants from rainfall, wind, insects, diseases. They're all being separated out. Then you are maintaining light and temperature inside. That gives you an opportunity to grow crops throughout the year. That's what the greenhouse is, right? A protected system. Although they're emperors, they have everybody with them, right? So he had a doctor, a personal doctor, and this doctor said, you have to eat a melon. You know melons, the fruit, right? Melon, cucumis melon. That's what his doctor said. Eat every day. If you eat a melon every day, you will be healthy. Well, the poor emperor Tiberius lives in a place where they can't grow anything in winter. It can get pretty cold in winter. So he was scratching his head and he ordered his gardener, said, I don't know what you do, I don't care. If you don't get me every day one melon, I'm going to get you up. You know, maybe he said, if you kill him, whatever it is. So this gardener got really worried. He doesn't know what to do. In winter it's cold. It's too cold that he can't grow melons or anything outside. So he came up with this idea. He basically built 4 walls, not 3 walls, okay? Big room like this, and then he put some sheet on top. No carbonate, but he found something. There is a Latin name for that, but I'll tell you what exactly it is in a minute. It's called lapis sativus. Lapis sativus. I don't need to write about it, but basically what it is, it's nothing but mica. You know mica? Mica is a translucent material, right? And what mica did was, it was allowing what? A little bit of light inside, but he built 4 walls around it, and so he could bring all of his cucumis plants on a cart. So horses used to, carry those big parts, mud parts with cucumis plants into the structure, cover it up. And that is how he used to protect them, especially at night times when it gets really cold. He used to protect the crops and then take them out in the morning. He's basically producing crops in a protected environment, isn't it? They didn't call it a greenhouse, okay? But it is sort of like that. So we think that is the first instant where we can say that it's sort of like a protected culture, okay? They're still struggling with pictures, but let them do that. In the meantime, I'll keep talking. I know the content, so I'll keep talking. The next, when you go through the historical records, the next evidence we have comes from South Korea. In South Korea, it also gets pretty cold. By the way, South Korea, it snows a lot in winter. So they have to protect their plants. So what they used to do is, they used to build wooden structures called ondal, O-N-D-O-L, ondals. What it is basically simple. It's like a basement, a sort of what you call ground floor, where they used to heat, they used to burn the wood, and it releases heat, and they used to send that heat through some form of pipes to the next level where the plants are there. So they're heating it. Temperature control. That's another evidence we know that many centuries back, still people were doing it. The Dutch houses were also familiar. In the Netherlands, in 1600s and 1500s, they used to do the same thing to keep those bulbs, the tulips and beautiful bulbs, all the time, survive there. So we have some evidence that way back, these things were happening. It's nothing new. They were not calling it like greenhouses, okay? But the first kind of evidence for this sort of protected culture comes from England, UK. Okay,
built the glass houses. You know the glass houses? Those big wrought iron structures, classical, structures. The English were all about, they were going all over the world. They were conquering different countries. So these people were picking up some plants, interesting plants from different parts of the world, and they had to protect them. Some of these plants are, tropical plants. You can grow them only in India, maybe in Africa. But if you take them to England, they may die. So they wanted to build a glass house only to protect those plants. It was their property. Okay? Interesting thing, because of those glass houses, glass became so popular in England. And they levied a tax on glass. Government said, oh gosh, everybody's using glass. We don't have that much glass, so we have to put a tax on it. So common man could not afford for glass. Glass was very expensive in England because of these things. You need a glass for windows, right? Otherwise cold air can come. So people used to put something else. Glass became so expensive. But just a digression there. But then modern day greenhouses are totally different. I can give you some more examples. Around 1650s, 1700s, there are some structures what we call orangeries. Orangeries. Okay. I hope we had. Oh yeah, there it is here. I want to show you a picture of orangeries. This is how it is. Let's use the arrow. Monitor this. For that. Where do you want it? Okay. So look at that. That is an orangery. Okay. So you have all the contents, so no need to worry about it. You can read it later. But look at that orangery. What do you see in that picture? What is evident for you? Immediately when you see that picture, what does it tell you? It has got what?
Windows.
Big windows, right? Big windows. Why are those windows there?
Sunlight.
For light, right? For light. And those windows, they used to face south sides. So you are, India is closer to equator, but you go to European countries, to United States, winters are pretty dark. We don't get a lot of light. Because you're closer to equator, both during summer and winter, you get somewhat similar daylight, 12 hours of daylight. In the United States, where I come from, even at 9 o'clock at night, there's plenty of sunlight. Okay? It's fairly bright, even at 9 o'clock. In winters, we don't get any light until 7:30 in the morning, but by 5:30 p.m. it's dark. We don't get a lot of light in winters. Okay? Whatever light you have, that comes from southern side because of the angle of sun. Sun is on a low angle in winter, but that light comes from southern side. And that's the reason why those windows are facing south. You can see that picture next to that is sort of like a cartoon, but that's how it used to look. That orangery that is still in place. This picture is an orangery in the United States, in Maryland. It's a state. Maryland is a state, and they are preserving this orangery just as a historical thing. But it used to look like that. You see, people are carrying orange plants, citrus plants. Oranges. They were growing in pots, and they used to bring them in winter inside those structures. That's why they were called orangeries. There were also pineries. Pineries. What are they growing if it is a pinery? Pine. Why would you go pines? What else? Pines. Pineapples. So they were growing pineapples. That's why they used to call pineries. George Washington is the first president of the United States. He had a pinery for himself. He used to grow pineapple inside that. Some examples of that. But, I will say before I go to this slide, I want to show you one more picture from this previous slide. Interesting picture. This is not moving back. Oh, there it is. Sorry, it might take a little. So look at that Google Earth picture. So this is Spain, okay? And it's called Almeria. All that white color, that's greenhouses. You are seeing it from space. You're seeing from space, all that white color greenhouses. 26,000 hectares of greenhouses space. This region of Almeria produces vegetables for the entire Europe. Okay? Right below that is Mediterranean Sea. It's very warm climate. It's pretty hot sometimes. And they have a lot of labor coming from Africa. So right below that Mediterranean Sea is the continent of Africa. So a lot of people from Africa, they want jobs, so they go to this region, they work there. It's very harsh to work in the hot climate, but they work there. 26,000 hectares of vegetable crops. They ship to entire Europe. It's not Netherlands or any other country producing for Europe. It's this Spain. Okay? And that is commercial greenhouse production. Okay? That is commercial greenhouse production. Similar things you can see in China too. China, Spain. These are the two big greenhouse producing countries. Then comes many other countries, France and Israel and the Netherlands and maybe Kenya a little bit, US. Okay, these are the top 7 or 8 countries. But the two big countries are China and Spain. Spain dominates total Europe production. No one else. Because they got the sunlight throughout the year, pretty close to equator. But I just want to tell you, this whole greenhouse industry, the greenhouses, from those initial fancy hobby style greenhouses, they completely became such huge commercial operations now. Okay? In different parts of the world you have different types of greenhouses, and that's what I wanted to do on this slide. So look at that, these are the 4 standard greenhouse designs you will see all over the country. But let's talk about A. Now these pictures are a little bit stretched here, but you might see it better on your own presentations. But that one top left A, that's called a Venlo style greenhouse. V-E-N-L-O, Venlo style greenhouse. Venlo greenhouses were invented in the Netherlands. You see, the Netherlands, the country, is right next to Germany. Okay? This World War II was happening, and Germany was invading everybody, right? In Europe, they were invading every country, and it was so easy for Germany to occupy Netherlands. It's just, Netherlands is such a small country, Germany is a huge, big country. They even occupied France, so the Netherlands was like that for them. When the Netherlands got occupied, the entire country was destroyed pretty much. After the Second World War, there is a small town called Venlo. The name of the town is Venlo. Their engineers came up with this design. For them, the problem was winters. They get a lot of snowfall, it can get cold, but they want to produce tomatoes, peppers, solanaceous crops. So what they want to do is they want to come up with these tall greenhouses. These greenhouses are glass greenhouses. Okay. These are glass greenhouses, tall. The reason why they're tall is they want to grow tomato crops, wine crops, right? They can hang them up. But glass was also helping them. It allows a lot of sunlight, and you'll learn a lot about that later on. Glass allows a lot of sunlight, so they need all the sunlight. Tomatoes need a lot of sunlight to grow. So the glass was good. Glass also is another advantage of glass. These glass panes, they are put together, but there are some small gaps. Through that gaps, the air can escape, meaning the humidity is less in glass greenhouses. Okay, so there's some advantages. You'll learn about those things later. Don't worry too much now. But they came up with that Venlo style just because of the need. Now look at B. B is a slightly different greenhouse. We call them as solar greenhouses. These are more popular in China. Solar greenhouses are more popular in China. The concept is very similar to the orangery. But what you are seeing there is one side is a wall and the other side is the car. Okay? And that car is facing south side. So just to let sunlight inside. At night time, what they do, they roll a blanket on top of that. The blanket holds the heat inside, so it won't get too cold. At night time, the polythene can, what happens is the heat can escape as a radiation, infrared radiation, and you learn about that. But they want to hold the heat inside the greenhouse. So because if the heat is lost, the greenhouse can get pretty cold, and plants won't grow, so they put a blanket on top. Just like we use a blanket, right, in winter when we go to sleep. Just like that, they put a blanket. That's a solar greenhouse. The heat comes from sun in the morning, everything gets warmed up. At night they close it, so keep the heat inside. Solar greenhouses are very popular in China. They're very cheap to build. Simple structures, but they have acres and acres and acres of solar greenhouses in China. Now here is the, look at number C, what we call the Parao type. These are the greenhouses that I showed you in Almeria. You know, that 26,000 hectares of land. Those are the greenhouses. There's a very, look at that, it's a very cheap structure. There's nothing much there. There are some pipes, and then a polythene is put on top, and it's just covered. They want to protect it from rain, okay, and they want to grow everything inside. Very, very cheap structure. Those are called Parao style greenhouses. It can get pretty hot inside, but they want, the reason why they went for this is they just don't want to invest in a lot. They want to build a huge area, 26,000 hectares of greenhouse space. That's why they went down to Parao style. If you look at other parts, so here is a sort of like a sawtooth, what we call a naturally ventilated greenhouse. These are more popular in India, right? You might have seen these type of greenhouses everywhere. What you're going to see is sort of like a roof ventilation and a polythene cover. But the bottom line, what I'm trying to tell you all is, there are so many designs, but the driving factor for different designs is the local climate. If it is snow, like in Netherlands, they were going for tall glass greenhouses with a, sort of like a A-shaped roof. You have Parao greenhouses, solar greenhouses, and simple poly houses, naturally vented poly houses. All of them came up because of the local environment. Okay? So different types of designs are there. All right? So the commercial part of the greenhouse, the commercial greenhouse are totally different from those hobby style. That's what I want you to remember. The original hobby style were expensive, glass built, but they were not for commercial purpose. They were fancy hobbies. But nowadays it's not the case. It's all more commercial greenhouses. Okay? I also want to touch base a little bit on the covers. We kind of talked about glass, polyethylene. So let me explain a little bit more. Globally, there are 3 types of coverings you use for greenhouse. Those 3 are shown here. And you'll learn about these coverings in detail when we go to the greenhouse designs chapter. But I just want to introduce the 3 major types: glass, polyethylene, and polycarbonate. Those are the 3 covering materials we use. These are the materials we use to cover a greenhouse. This material is so important. This is what is acting like a barrier, a boundary between external environment and inside of the greenhouse. Therefore, it is responsible, it is important for temperature control, it's important for light transmission, it's also important for stopping pests and diseases to get inside the greenhouse, right? But there are 3 major types: glass, polyethylene, and polycarbonate. Briefly about them, glass is expensive, okay? But glass has really long durability, meaning you can put a glass and for 20 years nothing happens. Long durability. Compare that with polyethylene. Polyethylene, you have to replace it every 3rd year. They'll tear away, sometimes the color changes to brown. Okay, so it's glass in that sense is much more. But it's expensive. Polyethylene is the cheapest. Right? So you have choices. People can choose whatever they want based on their situation. But then came the polycarbonates, and these came like in the 1950s. It's intermediate to both glass and polyethylene. Polycarbonate is about 10 years of life. It is not as expensive as glass, but it's also not as cheap as polyethylene. Okay? So people have choices, options. But again, if you ask me which is the most commonly used, 80% of the greenhouses globally use polyethylene. For a simple reason, it's the cheapest material. We don't care, we'll replace it every 3rd or 4th year. We don't want to invest a lot. Okay, so those are the 3 most important coverings, what we call glazing materials that we use. Okay? Like I said again, this chapter is about introduction. We're going to dive into each of these and learn more about these things. So we talked about so far, the kind of like the history of the greenhouses, right? I talked about how the greenhouse became popular from Emperor Tiberius' time all the way to the Almeria commercial greenhouse, 26,000 hectares. The total change with time, right? We looked at some designs, isn't it? I've shown you Venlo styles, I've shown you, naturally ventilated greenhouses, solar greenhouses, paral greenhouses. We're now talking about generally what these coverings are going to be, right? Like that, I also want to talk a little bit about here temperature control, okay? Now, we'll dive deep and do little math also in your activities later on temperature control, things like that. But I want to talk about two things. Whenever we talk about temperature, we are talking about two things, either cooling a greenhouse or heating a greenhouse, depending on your location. In summer, you have to cool a greenhouse. In winters, probably you have to heat greenhouses. Where I come from, we have to heat greenhouses. Outside can be 0 degrees Celsius in winter for us, 32 degrees Fahrenheit. Crops requires at least 20 degrees Celsius, 70 to 75 degrees Fahrenheit. So when outside is freezing, you can't maintain the temperature inside unless you heat the greenhouse. So we heat that. We also cool greenhouse in summer. And an important major discovery that happened was this psychrometric chart. Now we'll learn about the psychrometric chart, but what this tells you is that for a given outside temperature and for given relative humidity, it will tell you what will be likely the temperature inside a greenhouse. Okay? You can do mathematical calculations and you can tell that. That's what the psychrometric chart is used for, and that's why I put there. It's a company, it's a big company, Carrier company, it's an air conditioning company right now, but Carrier is the person who invented this chart. He did the math, physics. Okay? It's an important discovery. But what I want to tell you is the way we cool greenhouse, because cooling is more important where you are from. It can get pretty hot rather than heating. But the way we cool greenhouses is, do you remember these air coolers? In summers we used to have air coolers, right? There used to be a box, and you used to have some plant material around it. Water will be trickling down. So what's happening there? What is the mechanism? Anybody can explain? How is cooling happening? Not condensation, actually. Anyone else?
Actually, when the hot air collides or interacts with the plant material, which is wet by the
Yep.
water that is taken up by the pump,
Yep.
it transmits the hot air, ultimately turns cool when it get in contact with the cool surface,
Yep.
and then we receive the cooler air.
Exactly. She described exactly what it is called, evaporate. What's your name?
So, Ruchika.
Ruchika exactly said what it is called, what we call evaporative cooling. Evaporative cooling. It's the same thing that is happening in a clay pot. When you pour water in a clay pot, the water is cooler. Same mechanism. Egyptians, they kind of discovered this. They used to hang wet cloth on the windows, so people used to sit inside, and when the wind is blowing, you get cooler air inside. It's called evaporative cooling. And just to add to what she said, basically the air, hot air, is coming in contact with cold water that's flowing through the plant material. There the heat exchange is happening. The heat from the air is exchanged with water. Water takes that heat and it evaporates, right? Latent heat of evaporation. So water takes that heat, it evaporates, but the air is leaving the heat to water, so it gets cooler, and the cooler air gets into the facility. That is exactly how the greenhouses are cooled. We call it fan and pad system. All right? We call it a fan and pad system. And you will learn about fan and pad system, the details, specifications, how do you build a fan and pad system, fan capacities, pad, everything in this course. But that's how we cool greenhouses. A fan and pad system, and the method is called evaporative cooling. There is also another method called fogging. You just spray tiny, tiny droplets of water way at the top of the greenhouse where the heat is there, and the water does the same thing. Water absorbs the heat from the air, evaporates, becomes humid, whereas air gets cooler. The same mechanism, evaporative cooling. Okay? We'll talk about different methods later on, but remember that's the key way of cooling greenhouse. When we get to heating part, we use fuel, we'll burn, we use natural gas or wood, even electricity. We create the heat and we distribute that heat into the greenhouse. We to talk about that. That's little less important in this area. Cooling is very, very important. Okay? But that's an important discovery. The reason I'm showing all of this is these are the important discoveries that has happened in the last 100 years that paved for that commercial greenhouses. The 26,000 hectares of greenhouse space, it just didn't happen like that. There were so many technologies, there's so many discoveries that have happened in the last 100 years that made this as a big, huge commercial industry. Okay, the discovery of polyethylene, and you can Google and see the polyethylene is a sort of like an accidental discovery. A scientist forgot something and left it out and went away overnight and came back in the morning and found something new there, and that became polyethylene. It's everywhere in our environment now, right? Everything is polyethylene bags. Okay, accidental discoveries. These are the kind of discoveries that paved for that huge industry. Okay, that's why I'm kind of pointing snapshots here and there, the important things. Okay, let's move on. Let's talk about lighting, artificial lighting. Do greenhouses in this area, do you use lights in winter or at night time? You don't turn on the lights? Okay. But lighting is so critical, and even you don't use, you have to provide lighting. First of all, you have to measure the amount of light, and if the light is not enough, you have to add lighting in greenhouses. Okay? And this is called artificial lighting. Originally, we used to use what we call high pressure sodium lamps, HPS lamps. Again, this is just an introduction. Don't worry too much about these details. These are yellow color lamps. You know, if you have seen some pictures, the greenhouse looks yellow in color. But nowadays, we are moving on to LED lighting. Okay. And you can see all kinds of LEDs there. I just put some pictures here. The first one, you know, the artificial light that we discovered is called carbon arc lamp. You see that the 1A is carbon arc lamp. But I think the more important thing is the B, the halogen lamp, what we call MAS, the incandescent lamp. That's the discovery Thomas Edison, you know. Thomas Edison discovered the lamp because that's the master one. And then we also have high-pressure sodium lamp C, and now you can see all colors of LEDs. But the most important LED is the blue LED. And I'll talk about that more. From blue LED, we can create all colors. And it didn't happen until 1960s. Some scientists in Japan discovered it. They got a Nobel Prize, actually. The blue LEDs are now so cheap, 10 cents, or maybe even less. I'm saying in cents. But $1 has 100 cents, like 1 rupee has 100. I say, likewise, $1 is 100 cents. It's just 10 cents is what that costs right now, the blue LED. From that blue LED, we put some coatings on that blue, and in doing so, we can get all colors we want. We can get green, we can get red, we can get far red, whatever colors you want. And that is the reason why LEDs are so popular. You can customize the colors of light you can give to plants. Okay. Later this afternoon, we'll talk about light composition. But LED discovery is another big thing that has happened that has paved for the huge growth of this greenhouse industry. Greenhouse designs, coverings so far, temperature control technologies, lighting technologies, and then the other one I want to talk about is hydroponics. This is another important technology that's paving way for huge adoption of this. Hydroponics is basically meaning growing plants without soil, right? I want you to remember this. The word hydroponics is used in a very general sense. For example, cocoa coir, that's what you call here, right? Coir, peat and coir. There's artificial media. They are also considered hydroponic media. Right? Okay? Hydroponics is not just pure water culture. You can do that. Okay? But these things are also important. So peat, coir, their discoveries, their optimization, composition, things like that, really pay. But the most important thing I want to talk about, a little bit of history, here is about Justus von Liebig. So this guy is a chemist basically, and he found out that plants don't really require soil to grow. He said that soil is just there to provide support, but if you can somehow come up with a support for the plant and then provide all the nutrients they need, they will grow. You see, this Sachs doing an experiment here. He has a small test tube where he filled it with some solution, and then he was started growing. It was like in what? I don't exactly know the year, but it was like in 1800s. He was actually able to show that hydroponics works. So without soil, there are so many advantages. You can now grow crops in the middle of Mumbai, in the middle of Bangalore, where there is no land. But you can use hydroponics to grow crops there. Why do you want to grow crops in the middle of urban centers? Because that's where people are. That's where demand is. You can provide fresh food to growing population when you grow with hydroponics. So there's another technology that's growing a lot. I just put some names of other scientists who discovered different elements for plants. So that discovery of what really plants need to grow. What is that fertilizer? People never knew anything. People thought, oh, you put some seed in the soil provides everything and they grow. But then came these scientific discoveries. People were actually figuring out, no, there is something else. There are some elements that plants take. When I talk about nutrition, you will learn about the 14 different elements that plants take from soil. Essential elements. And these people found them. You know how they found it? Very simple. They took the plants, they burned the plants, they made ash from the plants, and they analyzed the ash, and they found many elements, but 14 of them were essential. That's how they know these are the elements, and they know that the only way these elements are going into the plant is through the soil. So then why not just give them elements through water and take up the soil out of the picture? That's hydroponics. This technology, peat medium, coir production, pure water, nutrient culture, they're all paving way for rapid growth of this industry. Okay? So different things, right? From a simple hobby style, I've shown you a picture where it's a huge commercial operation, but it just didn't happen like that. A lot of things were responsible for that. Designs, coverings, temperature control, artificial lightings, hydroponic crop production. All of these are important. That's why this industry is growing right now. Okay? And this is, I think, the last slide for this lecture. But the question I'm asking is, where is this going in the future? What will happen in the future? Yes, it's developing. In the last 50 years, it's growing rapidly. Where is it heading? Right? It's difficult to predict anything, right? If I ask you what's going to happen to you tomorrow, you don't know. I don't know what's going to happen to me tomorrow. Right? Nothing's going to happen. But bottom line, we are trying to say what's going to happen tomorrow based on what we know from today, based on what are the challenges we are facing today. And that's why I put some points here. And the first thing is, like I said in my talk, they're going to play an important role in food supply. They're not going to replace conventional field production. No, they're not going to replace that. It's not going to happen. Agriculture will be there, but it is going to supplement significantly. We may shift our model of producing healthy vegetables completely in greenhouses with time. So that can happen. The other things I think will happen is a lot of technology will come into it. Sensing systems, IoT systems, machine learning, AI, to predict the environment, make automatic changes. Wow, the environment is changing, we need optimum temperature. Over there is less temperature, over here it's more temperature. How do we manage that? It's not possible humanly. But maybe AI systems, technology, sensor-driven systems may become much more. We're going to introduce those things to you today. Okay? Carbon footprint. People will make sure that we're using electricity, we're using natural gas, fuels, we're burning fuels. We want to make sure that the carbon footprint is at minimum. We're not going to cause any more, in the future at least, global warming because of greenhouse production. So that may happen. Water use efficiency will increase, and it's already, power gone. That's okay. Water use efficiency is going to increase. We know that we can produce the same amount of crop in hydroponics with just 1/3 of water that we will use to produce the same crop outside. So let's take a tomato crop. Let's say, just hypothetical examples. To produce, let's say, a tomato crop, let's say you need 100 liters of water. We know that we can grow the same crop, get the same yield in a greenhouse, but with only 33 liters, a third. Already we are saving 2/3 of water. It may further increase in the future. Water use efficiency is going to go up. because water is a limiting factor. It's pretty tiny globally. If you know, there's only 1.78% pure water, fresh water on the planet. The rest of the water is in the ocean, salt water. And that percentage, 1.78 or 1.8%, hasn't changed in the last 2 million years. So it's not going to become more in the future. No. What we are doing is, we are taking that fresh water and we're polluting it. Industry, agriculture, urban usage, So water is a scarce resource. Some parts of the world have more water, some have less. India is already seeing the problem. If you go to some of these southern states, I don't know how the northern states are, but water is already, I know that Indo-Gangetic plain is getting polluted with a lot of nitrates because of agriculture. All the nitrogen is getting into the water. So we have to be very, very careful. So this recycling hydroponic systems is going to really play well. And the last but not the least, people might, and what's going to happen is people want to eat healthy. That revolution is happening. People want to know where their food is produced. Is it safe to eat? Is it healthy? Is it fresh? All those questions are coming, especially your generation is interested in that. And so greenhouses might be a solution for that. Growing food in urban areas where most of the people are. Harvest a crop, give them next day. Okay, so fresh. For most of us, we buy leafy greens, spinach and others. 2-3 days in the refrigerator, they'll look really bad. And then you throw them away. It's food wastage, isn't it? That's because it was produced somewhere, 1,000 kilometers away, came through some lorry transportation system and came to the shop, and from there to a local grocery, and then you went and bought it after 10-15 days after harvest. So you keep it refrigerated, they'll just lose their freshness within 2-3 days. But if you grow in an urban area, big cities, you cut and you sell tomorrow, you are giving those 14-day freshness to the consumer. And that's what the greenhouse might be going forward. It might help actually. So it is so important. It is a wonderful industry. It is growing rapidly. From, think of the Emperor Tiberius, lapis specularis, whatever the mica uses. From that stage to where we are today, thousands and thousands of hectares of greenhouse trying to supply food, healthy food to millions of population. And this happened because of all those wonderful discoveries and inventions. Lighting systems, temperature systems, designs, covering materials, hydroponic systems. And we're going to learn about all those inventions and discoveries in detail in this course. The first lecture is just to tell you how all of this has happened. Just to give you a perspective of where we are, what happened, how it has happened. So when we dive in, you know what you do. Okay? Any questions on this so far? Any questions?
So actually you were telling that we can shift these greenhouses in the city centers basically. Yeah. But in reality, the city centers are already so crowded that we are expanding towards the outskirts of the cities. So how this greenhouse will be possible in the city centers?
Yeah, and I'll give you an example. Chicago, big city. Okay, Chicago is a huge, big city. If you go to the downtown Chicago, it's all skyscrapers. It's not a single space there, right? You know where they're putting their greenhouses? Rooftop. Think of apartment complexes. They're growing everywhere, in every city. Why don't you put a greenhouse at the top of the apartment complex, supply food for the entire community living in the apartment complex? Problem is you have to carry things up there, but if you can get water and nutrients there, the space is up there. Sunlight directly comes there. That's one way. That's one way. But if you are even in outskirts, within, let's say, 30 or 40 minutes or 1 hour of a city, you can still bring fresh food, isn't it? Every day, if you need to. It's not that far. You can do inside cities, you can do just in the surrounding areas of cities. And this is where everything's going. I've seen in Chicago greenhouses of 3-4 acres size, big ones, on top of buildings. Now, there's another opportunity, and that we're going to talk about that, indoor farming or vertical farming, okay, in this course. This is not a greenhouse, but you can produce food using these platforms in urban areas. Just find a home people are not using. Some old houses, people are ready to sell, or they're going to destroy it, maybe build something else. You can probably take that structure and put some artificial lighting inside and grow plants in that building. Right? That's another way. So there are opportunities though. Okay, good question. Any more questions on that? Any questions? so far about this introductory class? Something that you did not understand? Or is it something you want to share? You think that's important? Feel free. Again, when you go back homes today, ask yourself, what did I learn? What is it that is not clear to me? And if you have a question, bring back in the morning. Okay, we can always start with some questions from previous class. Okay. I'm not sure time-wise. Anybody wants a gap? I think there's a gap of 10 or 15 minutes between lectures. We'll keep the breaks smaller because we took a lot of time with the program in the morning. So we can reconvene. Maybe just take a 5-minute break. Just drink some water. Stretch yourself.
Sir, actually lunch will be around 1.
Is it at 1 o'clock?
Yes.
What is the time right now?
12:23.
Okay. How is everyone doing? If I start another lecture, are you all okay? Yes. Does anybody need a break? Feel free to take a 5-minute break if you need. Or if not, we'll just move forward with the next lecture. We'll dive into the actual lecture on light. Is everybody doing okay? Any objections? Are we good? Okay. Then let's go on. Let's see if we can finish something before lunch. We have a class after lunch also, right? No, we don't have it. We have a lab after lunch, right? At 3 o'clock. I think we have a lab after lunch. So I have to cover. What I want to do is let's try this. I'm going the wrong direction. This one chapter? Where are the other chapters? Yes, there should be. There should be. Let him bring that. So what we'll do is I'm going to probably take that 40 minutes to start the lecture on light. Okay? There are, I think, if I'm not mistaken, anyone has the PDF with them? Did you all receive a PDF? A big PDF with all the chapters? No? Let me check with Dr. Ashutosh Singh. I actually sent him 2 weeks before the entire content so you can start writing down. Something happened here, but I'm going to start the lecture on light just to save time when it's coming here. But yeah, let's talk about light. So some questions for you. So to begin with, just to encourage all of you. So why do plants need light? Very simple question, right? Why do plants need light? Let's start with you. Why do plants need photosynthesis? So tell me about photosynthesis. What do plants do in photosynthesis?
They actually capture the light,
Uh-huh.
presence of light and CO2.
Yeah.
To make
They make sugars, right, from the light. So that's why the plants need light. What else? What else? Okay. What are the other reasons plants need light? Just photosynthesis? Anyone can think of other functions of light?
flowering is
Flowering. Great answer. So tell me about flowering.
actually some pigments are there.
What are those some pigments? Do you know the name? Starts with phyto. Somebody said phytochromes, right? PF, phytochromes, right? And they kind of short days and long days.
Far away, far red light comes
Yeah,
into
yeah.
the pigments contact and converts into.
So give me an example of, let's say, short day plant. Short days means these plants flower only when the day length is less than 12 hours. An example from this region. Do you know of any plant that flowers only when the days are short?
So rice.
Chrysanthemum. Is rice a short day plant? Chrysanthemum is a great example. Chrysanthemum, right? Kalanchoes. Kalanchoes. In the United States, we have plants of poinsettias. Have you seen poinsettias?
Yeah.
Christmas, they're gifted. Those are also they flower. So photoperiod. So photosynthesis is one thing, but photoperiodism is another thing. For photoperiodism, you don't need a lot of light. A tiny bit of light is enough to break the day cycle, night cycle, and it can create, for example, chrysanthemums. The way we produce chrysanthemums in the US. So if you let the chrysanthemums grow naturally, they only flower in winter. But if you want chrysanthemums to flower in summer, how do you do that?
We provide the intensity of light, duration of light. That is
How do you change the duration? I'm just asking questions.
Light,
light.
artificial lights.
So chrysanthemums flower when the day length is what? Is less, right? It should be less than 11 or 12 hours, right? Less than 12 hours. So in summer, probably the day length is longer than 12 hours, so they don't flower. How do you make chrysanthemums flower in summer? Let's say you have a greenhouse, okay? You're growing chrysanthemums, and you don't do anything, there is day length is more than 12 hours, chrysanthemums will remain green, vegetative. They will be producing branches and branches. You will not see buds. But you can do something to initiate flower buds. And that is called, how do you do that, Darpi?
So we can provide the shade
Shade won't work.
covering.
Shade is still light, right?
No, it
Shade won't work. What do you use?
reduce the amount of light entry.
We were talking about that, and she said dark period, you increase the dark period. How do you increase the dark period in a greenhouse? In summer. You cover the greenhouse with a dark black cloth. That's it. As simple as that. Not shade. Shade means shade will allow sunlight.
90%.
Still is enough.
Black.
Tiny amount of light is enough. It should be pretty much black. If you put black cloth, so in the US what we do is, by 5 p.m. or 4:30 p.m. in the afternoon, we put the black cloth.
Like wheat matter. Black.
It's black cloth. That's it. Very black. No light comes through. It's dark inside. Because if you interrupt that dark period, tiny bit, and I'll give you an example. There was this guy who was producing chrysanthemums, and at night times, the trucks, the trucks that they bring supplies, the trucks used to come to this greenhouse, and the trucks used to come with the lights on. So it's less light for a brief period, but those truck lights was sufficient to break the dark period. The plants were going through dark, and all of a sudden these lorries, trucks came there and they turned on the lights and then turned the lights off for a brief moment, so the dark period is broken. So tiny amount of light is enough to break the photoperiodic effect, and that's how we produce. Calanchos, poinsettias, chrysanthemums, all those Chardonnay plants, you can trick the plants. Okay, but that's another thing. So we're going to talk about light now. The topic is up. So in this particular chapter, I think this is what we need to finish before lunch. I'm going to talk about three things: light quantity, light composition, and light duration or photoperiod. Three things. I'm going to give you basics that you need. Okay, all the basics you need to really understand what light is really doing in crop production. In greenhouses, 85% of the light comes from sunlight, and the remaining 15% we normally give through supplemental light, artificial light. And I think it is important even in this part, when you think that the light levels are not sufficient, you have to add light, otherwise you won't get the quality plants. Okay? So tomorrow we're going to talk about those artificial light. That's the second chapter. What type of artificial lights are there, how do you select artificial lights, things like that. But today is about the basics on those three things: light intensity, light composition, and photoperiod. Okay? Now there's a little bit of physics here, but I'm pretty sure it'll be interesting to you. Alright, so let's start with this slide. This is solar spectrum. This is what you're getting from sunlight. So you take a let's say a sensor, and you measure what's coming. So sunlight is comprised of so many wave bands. That's what I want to tell you on this. So sunlight has gamma rays, X-rays, infrared rays, ultraviolet rays, radio waves, TV waves, and then there is also the visible light, the rainbow colors, right? Violet, indigo, blue, green, yellow, orange, all of those. So the sunlight is a package of everything. But what we are interested in for plants is this tiny band in the middle, and you can see right there, it is between 400 and 700 nanometers, what we call visible light, but there is a term for that. It is called photosynthetically active radiation, PAR. Why it is called PAR? Because that is the wave band, those are the wave bands that plants use in photosynthesis. Plants don't use X-rays, they'll get killed. Plants don't use microwaves in photosynthesis. They use this band, and the band is between 400